Too much? Okay. All right. Okay. So this is our last video in a series on significant figures. If you haven't watched any of those videos and you're not feeling confident on sig figs, you should definitely go back and check those out. In case you don't know, I'm Johanna Brown. I'm an actual high school chemistry teacher, and I'm hoping to make your life a little bit easier. So today we're looking at significant figures in mixed operations like these. So we'll go through some problems together today. I'll give you some hints, tips, and tricks and see how it goes. So we got our first problem up here. Let's light it up. So when I do sig fig problems like this and I have to track the numbers through, I like to just do the math. Get the math out of the way and then round at the end. It helps my brain process through it. It'll probably be better for you on a test. So let's see how this goes. We've got our problem up here, 11.9034 minus 3.68. We're going to then multiply that by 4.763. So using our order of operations, we're going to do the subtraction first, and we're going to get out of that 8.2234. All right, so then we're going to need to multiply that by the 4.763. A great skill to use when you're in chemistry is to estimate and make sure that the answers you're getting are making sense. So if we multiply 8 by about 5, we should expect to get a number around 40. So when I put this into my calculator, I got 39.1168. Okay. So right now we have a correct answer. It's just not correct in terms of sig figs. So we've done the math. Now let's track the sig figs through. I'll do that in red. So let's look up here. We have 11.9034 minus 3.68. We need to use our rule of adding and subtracting with significant figures, which means we can only go as far as the number that goes the least far to the right. In this case, it's 3.68. It only goes to that hundreds place, and that's where our uncertainty first comes into the number. So in this number here, that is the outcome of this operation, we're going to stop right there in the hundredths place as well. Okay. Now we're doing a multiplication. So we need to use our multiplication and division rules. So how many sig figs do we see here? Well, we have 3. How many over here in 4.763? We have 4 significant numbers. And our rule of multiplication and division with significant figures is you go by whichever measurement has the fewest number. In our case, that's 3. So our answer here can only have 1, 2, 3 significant figures. This is our first uncertain digit and where we need to end. So when you write your answer, you're going to need to check this and round it. So we're going to get 39.1 because the next number is a 1. So we round down. Perfect. 3 sig figs, and that's how we do that. Okay, so when you're thinking about these problems, you're going to do the math completely first, track the sig figs through, and then round. Let's do one more problem together. 62 times 7.38 minus 3.05. We're going to do what's in the parentheses first. So 62 times 7.38, we're going to get 457 what did I write? 56. Okay, 0.56. So that's our product of these two numbers, and then we're going to subtract the next number, okay? And we're going to get 454.51. Okay, so that's our answer. It's numerically correct. We need to track the sig figs through now. So multiplying up here, we need to use fewest number of sig figs. That's our rule for multiplication. We have 2 in this number, 3 over here. So the product of these two numbers can only have 2 significant figures. We're only going to go to that tens place in this number. Now when we subtract 3.05, notice that this does not actually affect numbers that we're considering significant, but you still need to do the math. Sometimes that confuses students. So this goes all the way out to that place before we have any uncertainty. So we'll see that come out in our answer here. So subtraction, we can only go as far as this tens place that's controlled by this number, so we can only report numbers to here. So we're going to get 450. We have a 4 back here, so we stop right there and we leave our answer as 450. 2 significant figures. Remember, zeros to the right without a decimal place are not significant. So we've reported 2 significant figures here. All right, let's go to our last problem, and this is your chance to practice. I find that students, they watch me do problems, they nod along, they say, yes, I get it, and then they go to do it themselves and they struggle more. So this is where the learning happens, guys. Why don't you start on this problem, get it on your own. We've got 71.56 plus 3.9423 divided by 0.626. So I suggest you pause the video right now, get the math, and then figure out how many sig figs the answer has, and we'll be right back. So looking at this problem, hopefully your math looks the same as mine. I did mine on my super fancy TI-89, so hopefully we got the same answer. So you're going to do the addition first, get a number that looks like this, then divide by the 0.626. Mathematically, you should get 120.611 as your answer. Now let's do the sig figs. Hopefully you already did this on your own and you're just checking your answer with me. So we are adding. So we can only go so far as the number that goes the least far. That's here in this hundreds place, right? So we can only go out to there. So that's going to control this answer here. We can only go to there, which gives us how many significant figures to work with? 1, 2, 3, 4. So we have 4 on top here. Well, how many sig figs are down here? Just 3. So our answer is being controlled by this because now we're dividing. We're looking at whatever has the fewest number. So our answer down here can only have 3 significant figures. We got 120.611. So to have 3 sig figs, we'll do 1, 2, and then we have a 0. Look to the right, it's a 6, so we round up. So our answer is 121, including sig figs. I hope that clears up how to do math and significant figures with mixed operations. If you have any questions, feel free to find us on Twitter at Too Much Chem, and make sure to subscribe for our future videos on intermolecular forces and vapor pressure.